Today we're taking some measurements with the Moore CT100HF TDR from Moore Test and Measurement and comparing them to the CT100B. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment and never connect to live equipment. Extra precaution must be taken with the Moore CT100HF as there is no self-shorting BNC connector and no internal protection circuit. This is the Moore CT100HF TDR. This is our first video featuring the high-frequency version. There are many similarities between it and the CT100B and some distinct differences. Both units have the same dimension and weight, both have virtually the same menu structure and interface, and working between the two is rather seamless as the interface for scanning and saving traces, connecting to CT Viewer, screenshots, printing, masking, and intermittent fault detection are all still in the same places in the user interface and all operate the same way. The main difference between the units is the resolution of the traces. As I mentioned before, the outside connection differs, as the self-shorting BNC that is standard on the CT100B would inhibit the resolution of the CT100HF. So it comes standard with a stainless steel SMA port or the optional end connector used for measurements in this video. The internal protection diode is also not part of the CT100HF, so extra care must be taken to discharge static before connecting to this unit. We recommend using the CT100HF in a controlled environment as the CT100B is better suited for field use. Doing a quick demonstration of the CT100HF with these Fogra cables. At first glance, the tray shows no imperfections like unexpected opens, shorts, kinks, or splices to the cable itself. Now let's take a closer look at the connectors. Here in CT Viewer, what looks like a tiny blip where the connector is connected to the test lead, we're about to see some amazing detail as I zoom in here. We can see that there are some drastic differences between the four connectors scanned. How can this instrument see something so small? It all comes down to rise time. The Moore CT100 series is a step pulse TDR descended from the Tektronix 1502B and 1502C. The Moore CT100B has a rise time of 95 picoseconds, which is considerably faster than the Tektronix 1502B with a rise time of 130 picoseconds. The Moore CT100HF, however, has a rise time of only 48 picoseconds. This sharper rise time gives stunningly accurate details when scanning metallic cables. Comparing the CT100B to the CT100HF side by side, using the same cables, zooming in the same vertical scale of 2 ohms per division, and 0.315 inches horizontal per division, the difference is quite apparent. When we increase the gain to 0.8 ohms per division, we can see some more detail on the CT100B, just not as detailed as the CT100HF. Going to quickly scan these 8 Fogra connections, comparing them side by side. Again, we can see much more detail with the CT100HF, and when I increase the gain on the CT100B, it does reveal more detail, just not the same as the CT100HF. Looking at these traces in CT Viewer, we can see that 1 is bad, 2 is bad, 3 is good, so is 4, 5 is bad, so is 6, 7 is good, and 8 starts out looking good till we see it's over crimped down here. We'll show how these defects can affect frequency transmission in a later video. There you have it, the Moore CT100HF from Moore Test and Measurement. Be sure to like this video and subscribe to our YouTube channel. Check out our website at mooretm.com. Give us a call or shoot us an email, and we'll see you next time.